Welcome, everyone. Welcome to the AITP Los Angeles August virtual meeting. Tonight's event will be current trends in blockchain technology with two outstanding speakers. The AITP chapter is a resource for people that are interested in keeping current on technology and encouraging ideas for innovation, as well as we provide strong networking opportunities. Next month, we'll have a pre-meeting networking session that is virtual. And we've got a great board this year. We've got Rick Peterson as president, Nilu Tao as programs co-chair, and also she helps focus on our members' experience. She's also facilitating tonight's webinar. Mitch Matsumura, our VP. Joan Samuels, in charge of membership and professional development. Carol Schlacker, in programs, a loyal board member, and always with plenty of ideas. Greg Klinner, our technology director, a longtime board member, and he keeps our website current. Also, I want to mention Stephen Laughlin, our past president, and who is a significant mentor to our board. AITP is part of a national organization that provides leadership and professional development opportunities for managers and technologists, and there's a network of hundreds of chapters across the nation. Our membership is separate, so the local LA chapter membership is separate from the national membership, and it's very inexpensive. So we'll give you more information about that a little bit later. And now I will turn to Nilu, who will explain the rules for tonight's webinar.
Hello, everyone. Welcome to the webinar today. So before we go into the actual presentation, so just some logistics on the webinar rules. If you're having any kind of technical issues or questions, you can post that in the chat section. So you can chat with the panelists and one of us will answer your technical queries. And if you have any questions for our speakers today, so please post that in the Q&A section. You are going to be muted, and also your video is going to be off for tonight's session. We are going to be recording this session, and it is going to be posted on AITP-LA's website. So you'll be able to see the presentation material and the recorded session on the website once it's complete in next few days. So at this point, I'm going to have Roger introduce our first speaker.
Great. So I'd like to introduce Dr. Gowri Ramachandran. He's a senior research associate at USC Viterbi Center for Cyber Physical Systems and IoT and Autonomous Networks Research Group. He will discuss IoT and blockchain, non-cryptocurrency applications. He will share what's becoming possible, how blockchain makes systems efficient and very secure, and he'll also discuss how blockchain is being incorporated into IoT devices and ecosystems, and how it can be integrated into existing applications. So Dr. Ramachandran, please start.
Okay, thanks for the introduction, Roger.
Perfect.
Okay, great. Good morning, good evening, everyone. So as Roger mentioned, I'm a senior research associate at USC Viterbi School of Engineering. I did my PhD in Internet of Things, and I graduated from KU Leuven, Belgium, and then I moved to USC in 2017 to do my postdoctoral research. So ever since I joined USC, we've been looking to apply blockchain technology to IoT and other applications that we encounter in smart cities and supply chain type of scenarios. So in this talk, I'm going to talk about some of the characteristics of blockchain technology, and then I'll be going through some of the non-cryptocurrency applications of blockchain. So predominantly, I'll be discussing some of the protocols and frameworks that we have developed at USC. And then I'll end this presentation by, introducing some design questions. So for example, if you're considering blockchain for your applications, then you can take these research questions into account before you can decide on whether to use the blockchain technology for your application. So that's going to be my agenda. So let me start by providing a high-level introduction to blockchain. So I don't know how many of you heard about Bitcoin, and if most of you have not heard, then I would be very surprised. Bitcoin is the what to say? This Bitcoin started the whole blockchain ecosystem. So that's laid the foundation for everything that we are going to be talking about today. Around 2009, this Bitcoin blockchain system was launched. In addition to this practical Bitcoin platform, there was a paper published by this anonymous author named Satoshi Nakamoto. And to this day, we do not know who is the real inventor of the blockchain. All we know is that Satoshi Nakamoto, created or invented Bitcoin. And we don't know whether this Satoshi Nakamoto is a single person or a group of people. To this day, we still don't know. So in summary, we still don't know who invented Bitcoin, but all we know is that it is an outstanding technology, and it introduced a sort of a novel method to have peer-to-peer cash payment. So when I say peer-to-peer cash payment, we are not involving any centralized authorities. Traditionally, when you do banking, you rely on a centralized banks, and they are the one handling your accounts, payments, and all that. But with Bitcoin, we learned that there is an alternative way to do payments without involving any centralized intermediary. And the way Bitcoin achieves this decentralized operation is through this concept called proof of work. So I don't know how many of you hear this term proof of work. Maybe I'll explain it at high level. So proof of work is nothing but a collection of compute nodes. These are deployed all over the world. Let's say that you want to be part of this Bitcoin network. All you do is, invest on some compute resource, that is buy a compute node and set up in your basement, and then you can participate in this Bitcoin ecosystem. So by proof of work, what we mean here is each compute node that is part of this Bitcoin ecosystem, they would be asked to solve a small cryptographic puzzle. This is like a complex computational task that you will be asked to solve. And all the computers that are deployed globally, they would all be participating in this puzzle solving process. And the node that successfully solves the puzzle, they get to propose the next block. And here each block in the blockchain consists of collection of transactions. That is, parties are transferring Bitcoin from one account to another account. These are called transactions. So if you look at each block, these blocks will have collection of transactions. So let's say that if you manage to successfully solve the cryptographic puzzle, then you are the winner of that particular round, which means that you will be rewarded with 1 or 2 Bitcoins. I think currently it's at 1 Bitcoin. So if you successfully solve a puzzle, you will get 1 Bitcoin as a reward. The reason why they are giving this 1 Bitcoin as a reward is because this computation process is extremely complex, and it requires huge amount of resources, and you will probably spending a lot of electricity to crunch this cryptographic puzzle, because it's not easy. It's not like a computation task that you start on your computer and it ends quickly in like 1 or 2 minutes. It takes an average about 8 to 10 minutes to successfully solve the puzzle on a typical computer. So a lot of people invest on this special compute nodes to solve the proof of work puzzle. And because of this proof of work puzzle, Bitcoin is able to get rid of the centralized mediator, because when you go through the centralized system, you're trusting that centralized system to do the right things. Whereas now since you're operating in a decentralized peer-to-peer ecosystem, there is no single entity keeping an eye on what is happening on this ecosystem. This is where proof of work is playing a critical role. Now, without solving this puzzle, there is no way the blockchain is going to progress. And the protocol is set in such a way that the progress of the blockchain is heavily tied to this, cryptographic puzzle. And there is there's no way the system can progress without solving the puzzle. Therefore, all the compute nodes are going to compete with each other. The nodes that successfully compute the puzzle is going to propose the next block. And once the block is, when they are proposing a block, the protocol says that you are required to verify whether the transactions are valid. For example, I cannot make a transaction. Let's say that I'm making one Bitcoin transaction to Roger's account, and I should first of all have one Bitcoin Bitcoin in my account to be able to send that to Roger's account. So I cannot send some money without having that money in my account in the first place. So these kind of rules are actually set in the protocol itself. And the protocol, when the block proposers are committing the block to the blockchain, they are required to verify these kind of things, whether I have sufficient balance in my account to make the transaction or to transfer the money from my account to another account. So all these things are described in the form of the protocol, and that protocol is what is driving the entire Bitcoin ecosystem. So everything is happening in this decentralized and distributed set of nodes through this protocol that clearly describes how the system is going to progress. And in addition to the proof of work, Bitcoin leverages well-known cryptographic protocols such as public key cryptography. And it also uses this ledger for storing the transaction history, because again, one may want to go and look at how their account has been used in the past. So you can actually go and look at this ledger. The ledger is currently open. There is no single entity managing the ledger. Anyone can actually go and look at the Bitcoin ledger today. So if, for example, if you look at Bitcoin, I think it's currently at around 600,000 blocks in length. Since 2019, there have been more than 600,000 blocks produced in the blockchain. That means 600,000 times people have successfully solved this cryptographic puzzle and proposed new blocks to the blockchain. And you can go and look at each and every block that is part of the blockchain, and you can look at what kind of transactions have been carried out. Another interesting statement that I would like to make here is all these transactions, they don't carry any personally identifiable information. So these are anonymous transactions, which is the reason why people who are so concerned about privacy, they are actually focusing more on this technology, and they are using this technology more and more. All the transactions are handled through this public key. That is the only information that is connecting to any individual. And public key is nothing but some long string of characters. And with that string of characters, you cannot actually identify a person on the Bitcoin network. So that is another advantage, and that is something that is attracting more people to this technology. So that's about Bitcoin, and that started this whole blockchain evolution. And the key components of blockchain, which I briefly talked about in the previous slide, the proof of work component that I mentioned is sometimes referred to as consensus algorithm in the distributed systems community. And this consensus algorithm is what helps the distributed set of nodes to agree on the state of the system. Because when you do everything through one single computer, that computer knows all the information. That one computer says that, hey, Gowri has 1 Bitcoin and Roger has 2 Bitcoin. Those details are part of this single centralized computer. Now, because you're operating in a distributed and decentralized setup, all the compute nodes need to agree on the state of the system. So in this case, the state of the system is Gowri has 1 Bitcoin and Roger has 2 Bitcoin. This information has to be part of these distributed or decentralized infrastructure. All the compute nodes that are part of the Bitcoin ecosystem, they are required to manage this information on their nodes. The way they manage this information is through this consensus algorithm. So that is one of the key components of any blockchain technology. So let's say that when you hear someone that, hey, we are using blockchain technology in our application, the next question you should be asking is what consensus algorithm you're using. Are you using proof of work, or is there another type of consensus algorithm that your application is currently using? And the next component is public key cryptography, which is the one ensuring the integrity of messages that are being exchanged in the Bitcoin network. This provides sort of the security to the whole ecosystem. And then the third key component is the distributed ledger, which is nothing but the blockchain itself, like the chain of blocks that is carrying the transaction information. And this distributed ledger has an interesting property. That is, this is a write once ledger. It means that once an information is written to the ledger, it cannot be modified. So that is another key advantage of blockchain technology. So so once an information is stored on this ledger, it is impossible to modify. And if you try to modify this information, you can modify it on your local computer, but then that local change will not be reflected on the globally distributed blockchain. Remember, blockchain is not stored and maintained on a single computer. It is actually stored and maintained on a collection of computers globally. And all these computers, store these blocks after going through this extensive proof of work and other sort of protocol, following the other protocols. And after going through all these steps, once an information is stored in the blockchain ledger, it cannot be modified, because you can modify it on your computer, but then that's not the global truth. The global truth is maintained on all the nodes that are globally distributed, and they can, if you say that if you tamper the information locally on your computer and saying that I only have 1 Bitcoin, but you go and write 3 Bitcoin to my account, but then when you submit the transaction, it won't be considered valid, because others nodes that are in the ecosystem, they will see Gowri has only 1 Bitcoin. It won't say 3 Bitcoin, because it's written following this extensive protocols that is secure, and that allows one to write transactions in a reliable and immutable manner. So those are the key components. So I think that's sort of the high level introduction. So we talked about Bitcoin. I just wanted to say a couple of words about Ethereum. Ethereum is another dominant platform in this space after Bitcoin. It also uses the same consensus mechanism, that's proof of work. And it also has the blockchain as a ledger. All the transactions are stored in the blockchain, and it uses ETH as a cryptocurrency. And it supports something called smart contract, which I'll explain in the coming slides. And then each transaction, there will be a small fee, when you use Ethereum for your applications. And currently, Ethereum is helping many startups to deploy decentralized applications. So this is one of the popular platform for startups in the space of finance and supply chain type of industries. So that's about Ethereum, and there are other blockchain platforms. So here Tendermint is another example, which is a lightweight blockchain platform, and it uses this consensus algorithm called Tendermint BFT, which stands for Tendermint Byzantine Fault Tolerant Consensus. This is different from proof of work. So here all the compute nodes, they will vote, and they don't solve any computationally intensive puzzle. So in a way, this is lightweight and works much faster. And also, when you use Tendermint BFT, you're not required to spend a lot of resources to solve any cryptographic puzzle. It's much faster, and it doesn't provide any support for cryptocurrency, but it's a platform for non-cryptocurrency applications. Therefore, we actually use this Tendermint BFT in some of our work. And then another interesting thing is Tendermint BFT even runs on Raspberry Pi. So if you own a Raspberry Pi and if you want to experiment with the blockchain technology, then Tendermint BFT is one for you to play with. So with that, I'll quickly go through some of the capabilities. I repeatedly mentioned that Bitcoin is sort of providing a decentralized infrastructure. If you use any blockchain platform, you're deviating from centralized operational model that you see in the slide. There is one organization A, and all the clients connect to that organization. That's a typical centralized model. So that is how you interact with banks today. Your bank is a central controller, and all the clients would typically interact with the bank. So that's the centralized model. But what blockchain offers is a decentralized infrastructure, and because of this proof of work and other clever protocols, you're able to have a decentralized infrastructure, and all the clients, they would actually be interacting with decentralized or distributed infrastructure. So now whatever operation that you perform in this infrastructure is visible to organization A, organization B, and organization C. So here I'm just showing showing the strength of the blockchain using 3 organizations. But if you look at Bitcoin, there are like thousands of nodes distributed all over the world, and there are thousands of organizations actually involved in your application. So blockchain provides this decentralized infrastructure that is more transparent. It is more transparent because all the transactions are actually going through this distributed infrastructure involving thousands of organizations. And the next key point is the immutable ledger, which I mentioned a little while ago. So it provides a write-only tamper-proof ledger, which means that once the information is written to a blockchain ledger, it cannot be modified. So the way the protocol is designed, whatever information goes to the blockchain, it stays there. You cannot delete it. So that's another key capability or key feature of the blockchain. And next is the payment support. All the blockchain platforms, including Bitcoin and Ethereum, they provide support for payment. So if you want to build any application that requires some sort of payment, blockchain already provides that capability. And there are some applications that requires tokens. Again, Ethereum blockchain platform is very well known for token-based applications. So again, these capabilities are already built into the blockchain ecosystem. And in some of our work, we are actually leveraging these token capabilities. And next important capability is the smart contract. So smart contract is nothing but a small piece of software that is deployed in this decentralized infrastructure. And this small piece of software allows you to define some rules. And this rule could be, if event A happens, do the following. And the following, for example, you can say that in the case of supply chain application, if my shipment reaches warehouse A, make payment to the supplier, for example. These things you can actually automate it by writing a small piece of code within the blockchain, and this small piece of code is now executing on the decentralized or distributed infrastructure. Let's say that when you send a transaction to the blockchain, it immediately triggers this small piece of code, and then whatever logic that you defined in this code will get executed as part of this distributed consensus process. So that is another key innovation that happened about 6 or 7 years ago in this space. So now the smart contract capability is being leveraged by a lot of applications. So this allows many applications to automate some of their business processes. You can actually define some of your business logic in the smart contract. And whenever you execute some transactions in the blockchain, the smart contract will automatically, execute some of your business logic without you doing any additional, work. So those are some of the key capabilities of blockchain. So with that introduction, we'll look at some of the non-cryptocurrency applications that we looked at in our research work. So these protocols and use cases that I'm going to talk about, these are all work carried out in our research lab at USC. So just wanted to let you know that. So most of the work that we do is actually in the space of IoT and smart cities. So I'll talk about how we are applying blockchain technology to this domain. So before I go into the specific protocols that we have developed, I just wanted to quickly talk about this I3, which is a community data marketplace for smart cities. So this is the joint work with multiple industries as well as the city of Los Angeles. So we are building this community data marketplace called I3, which looks like this. So let's say that you have a bunch of IoT devices or IoT data in your, in your home or in your neighborhood, and you want to sell that data to the application developers. So the I3 data marketplace provides the platform. So the best way to compare I3 with other types of ecosystem is maybe Amazon is a good example. So let's say that you are a seller, you want to sell a product. What you do is you go to the Amazon marketplace, you register your product, and then buyers would actually go to the marketplace, search for the products, and if they find any interesting product, they will buy it. That's the process that's followed in Amazon marketplace for like digital goods. Physical goods. So here we are creating an equivalent for the digital data. So this is an IoT digital data marketplace where people with IoT sensors, let's say that you have a temperature sensor or air quality sensor, you would go and post that information to this digital data marketplace saying that, hey, this is my latitude and longitude, and I have this temperature sensor or air quality sensor, and I'm willing to pay, I'm willing to sell this sensor data for, let's say, 1 cent or 10 cents or whatever. And you set this information and register the data product in the marketplace. And then the application developers can actually go to this marketplace and buy this data to build applications using your data. Now, one question that may come to your mind: why do you need such a model? Why can't application developers themselves deploy sensors and build applications? If you look at smart city type of setting, it is very complex for city to deploy sensors or in each and every street, because it's going to be extremely expensive, and they have to invest a lot of resources on maintaining these sensors. Now, through this data marketplace, we are able to collect data from existing deployments. City need not go and deploy their own sensors. Now they can actually leverage the existing deployments and use the data coming from those deployments to build cool applications. One of the applications that is currently under development using this I3 data marketplace model is a parking application. It's called Find Me a Spot. This is still in the works, but you can check out the link. So this Find Me a Spot application is actually collecting parking data from multiple parking structures in the LA County area. So currently Find Me a Spot provides parking data from downtown LA, Westwood, Hollywood, Marina Del Rey, LAX airport, and so on. So now, using this I3 data marketplace model, all these parking providers, they can actually make their data available to the application developers. So in this case, the city of LA is interested in building this parking application. Now they are collecting data from these various parking providers. They are distributed throughout LA County. All they have to do is register their data to this data marketplace, and the city of LA can actually get the data and make that information available to the users. And if you go to this link, findmeaspot.lacity.org, you can look at how many parking spots are currently available in the downtown streets. You can actually look at how many spots are free at this point. This is real time. So you can see how many spots are currently available in each street. And then let's say that if you're going there, you can actually use this app to, decide in which street you're going to park. This is a problem that city is kind of interested in solving. And now we are able to, provide this architecture for city to, collect data from multiple parking providers and make that data, available to the community members using this app. So that's an example of an application that is using, the data provided by community members. But if you look at this application, there is this data sharing component. So let's say that the parking providers, they are sharing their data with the application developers to build this application. So there is this data sharing component. So how can we build this data sharing protocol that incentivizes people for selling their data using a peer-to-peer architecture? Because here in this platform, we are saying that the seller is required to post their information to the i3 platform, and the application developers are required to buy the data from i3 platform. What we want to create is, hey, can we do a peer-to-peer data sharing platform or protocol without involving any centralized intermediary such as i3? So that's our goal here. So we actually created this protocol called Streaming Data Payment Protocol, or STPP in other words. So this is if I have to describe it in few words, this is data for payment protocol. That's all. So let's say that if you have a data and you want to sell the data to another party who is interested in using your data to build applications, then using STPP, you can sell that data and get payment in return without involving any centralized intermediary. So that is the key highlight of this protocol. And if you use any web browser or any website today, you're following this client server model. You're actually using this TCP protocol, and what TCP does is it just fetches this files from a remote server and showing it on your browser. So now you're just collecting data from a remote server, and then that data is rendered on your browser, and then you're just browsing through the website. So that's how TCP works today. And our goal with STPP is that, hey, how about creating a payment channel as well? So when you get a data from a remote computer, can we also incentivize the remote computer because it is providing some valuable data to you? So that's how the STPP idea emerged in our lab. So now, following this protocol, anyone can actually sell data to any application developers without involving any centralized intermediary, and you can actually get some incentives for selling that data. So we have this protocol already developed, and we have the software released as well. You can find the software in this web page, in this link to experiment with. You can actually use the code today. You can download it and try it out on your own. That's one protocol. So here in this particular protocol, we are actually leveraging the cryptocurrencies that are available in the blockchain platform. And we are also using this immutable ledger to store the transaction. So that those two capabilities are leveraged by this STPP. But if you look at the i3 architecture again, which I mentioned a little while ago, it uses this centralized architecture. Everything is going through this i3 platform. And today centralized architectures are not well known for high trust, because that centralized administrator, they can actually manipulate that information, and they are completely in charge of whatever is happening on their computer. They can go and delete some data product, or they can they can shut down their computer if they don't want to serve customers. They can do all sort of things because it's right now controlled and managed by one single entity. They can manipulate all the information that is happening in their infrastructure. So that is one big downside of leveraging a centralized architecture. So to overcome this problem, we again created a blockchain-based data marketplace, which does not rely on a centralized intermediary. Now everything is going through this decentralized and distributed blockchain-based infrastructure. Now using this new platform called DDM, or decentralized data marketplace, the sellers and the buyers, they can actually do all the transactions using this blockchain ecosystem, and all the application logic is defined in the blockchain smart contract, and the seller and the buyer would just be interacting with this blockchain smart contract to build their application. So again, we have this product already built, and you can find the demonstration of the decentralized data marketplace in this link. So I'll be sharing the video. I'll be sharing the slides after the talk today, so you can go to this link and take a look at it. But for this application, we leveraged the Ethereum blockchain platform, and we also used STPP for handling payments. But I just wanted to make one, high-level point here. Blockchain allows you to, allows you to build a decentralized version of a centralized application. So whatever application that you're currently using following a centralized architecture, you can build that same application using blockchain to sort of create more transparency and more accountability. Now, whatever information that is going through blockchain is more transparent, and it is stored in this immutable and tamper-proof ledger. Therefore, it allows one to have more trust in those type of architectures. So again, in this application, we are leveraging the cryptocurrency platform, and also immutable ledger is used to store some of the transactions in the tamper-proof ledger. And we are also leveraging the smart contract capability to handle all the key functionalities. So then I'll just talk about one more application, then I'll move to the design questions. So here we also looked at how blockchain can be used in supply chain type of applications. So if you look at any supply chain applications, you typically see many stakeholders or many players in those applications. For example, here there is a farm, and then there is a processing industry, and then there is a distributor, and then a retailer. So typically, in these type of ecosystem, the goods, it moves through these different stakeholders, and when it moves through these different stakeholders, it is important to keep an eye on what is happening to that good. In particular, you want to keep an eye on the temperature, humidity, and expiry date, and those type of information. And you also want to ensure that there is no contamination happening in any of these supply chain endpoints. And then you also need to ensure that all the parties are honestly reporting that information throughout these supply chain ecosystem. So today's supply chain deployments, it typically follows a centralized architecture, meaning that if any company is involved in supply chain operations, they are typically required to follow a sort of a centralized model in which they are required to report that information to the other parties in the ecosystem. And there is no visibility. Any operator or any administrator can actually manipulate that information if you follow the centralized architecture, because it gives them complete control to modify the data when it is in their control. So now how can we apply technologies such as blockchain to sort of provide more transparency to supply chain applications? So in this space, Maersk, which is sort of a shipping company, and they are already experimenting with the blockchain technology. You can check the video later. And then Walmart is also deploying a blockchain-based solution to track some of the food products. So there's already some effort in this space by big players. So you can certainly check that out. So the reason why they are adopting blockchain for supply chain is to address these problems that you see in this slide. Today's supply chain lacks transparency because everything is going through the centralized infrastructure, and it's very difficult to process payments because it may get delayed, or because of a lot of paperwork, the payment may not happen on time. And then because of the centralized nature of the supply chain system today, there is a possibility of data misrepresentation and corruption. And then it's very difficult to operate at a global scale, and it also poses a lot of interoperability issues. Your system may not easily connect with systems in other countries or other continents. So all these sort of limitations are currently existing in supply chain systems. So what we propose to these type of applications is a publish subscribe communication model. At high level, this is a sort of a three-party protocol or three-party messaging system. The three parties in the system are publishers, broker, and a subscriber. Publishers are anyone with information that they want to share with other parties in the ecosystem. They would publish that information to a broker, and broker would then relay that information to the subscribers. So this is called publish subscribe communication model, and it's been around for more than two to 2.5 decades. And this protocol, as you can see from this slide, it follows the centralized model. Everything is going through the centralized broker. And I've mentioned several times in this presentation that centralized architectures uh, are not great, and they are vulnerable to central points of failure. Therefore, you need to have a sort of a decentralized architecture with more transparency and more accountability. But then today's real world applications, if you look at this slide, Apache Kafka is an example of publish subscribe communication system. PubNub is again another example. All these big players and big companies, they're actually using these types of protocols, this publish subscribe protocol, following this centralized architecture to exchange data with other parties in their application ecosystem. So this is a widely used protocol, but then the problem is they use this centralized architecture. Therefore, they are still susceptible to this central point of failure issue. So this is sort of the summary of the state of the art in this space. All the protocols that you see out there, these publish subscribe protocol, they are all centralized, and they use single organization model. Therefore, there's only one administrator managing the entire ecosystem. And if you have such deployments, it is going to introduce a central point of failure. We introduce a new protocol or new framework to solve this problem, and that is called Trinity, which is a research work out of our lab, and we published this to a top academic conference last year. And using Trinity, supply chain applications can actually be distributed among multiple organizations or multiple endpoints. Now, if they use Trinity, they can actually deploy consensus nodes or blockchain nodes on each of their supply chain points. Let's say that there are 5 warehouses involved in one physical good. Then all these warehouses can actually deploy these blockchain node, and all the information related to the product is actually handled through this distributed consensus layer or distributed set of nodes. And because of this distributed mode of operation, there is high amount of visibility. Now each supply chain endpoint can actually report that information to this blockchain node. And then once it's reported to the blockchain node, it immediately gets stored in this distributed ledger or the blockchain. And as I mentioned earlier, once the information is written to the blockchain ledger, it cannot be modified. Therefore, if you follow this protocol or this mode of operation, the companies can actually reliably transact with the other companies, because as soon as the information gets submitted to the blockchain, it's immediately visible to other parties in the ecosystem. If there is a dispute or if there is a problem with any item, they can actually go back and look at the blockchain. So that is the high level idea with Trinity here. Again, we have created this protocol and made the software available as open source. You can actually go and download this software and try this out. Yeah, there are a lot of deep technical details here. In the interest of time, I'm not going through those details. But the high level idea is that Trinity allows multiple organizations to reliably exchange data with each other, and they can also deal with disputes thanks to the involvement of blockchain and its tamper-proof ledger mechanism. So here we are actually leveraging the blockchain technology, that is the consensus protocols, and also the immutable ledger for providing the write-only storage. So I mean, in the interest of time, I'm not going to go through some of these applications, but all these applications have sort of video demonstrations available. So you can actually click this, and this video explains some of these other work. But the high level point is we are also applying blockchain to connected and autonomous vehicle type of applications to let cars exchange data with other cars on the road. So because this is sort of a data marketplace, but now this is a data marketplace for vehicles. Now how they would be exchanging data with each other, and there are some challenges in achieving that. So we are addressing that challenge in this project. This video clearly explains it. So you can certainly go through that video to learn more about it. So I'm just skipping those slides. Now I'm coming to an end. I'll spend about 5 minutes on design questions and then conclude this talk. So I mentioned that blockchain is offering this decentralized infrastructure. It is providing transparency, it is providing immutable ledger and all that. But then it is not so easy when you're actually building a blockchain based application. One needs to take a lot of things into account before deciding which blockchain technology is suitable for your application. The first question is whether you want to choose a permission blockchain or a public blockchain. So what is the difference between permission and public? So Bitcoin and Ethereum are examples of public blockchain platforms. These platforms allow anyone to set up a node and be part of their application ecosystem. Therefore, you don't need any special permission. All you need is a decent compute node, and you should be able to download these protocols developed by Bitcoin if you're setting a Bitcoin, or Ethereum if you're setting up Ethereum. You just download it and set it up. You can do it today. So that's what it's called public, and anyone can actually go and join these platform. And because of this public nature, it is using a sort of a heavyweight consensus protocol or heavyweight protocols to ensure security and integrity. And that heavyweight protocol is nothing but proof of work, which I explained in the beginning of this presentation. Whereas if you use permission blockchain, sort of your identity is revealed to this organization that is running the blockchain. Let's say that USC is setting up a blockchain today. And then if you want to be part of this USC's blockchain network, you have to reach out to this organization, that is USC in this case, and then you tell them that, hey, I want to be part of your blockchain network. Then USC would actually go through this registration process, and then after going through that process, you can actually become part of this permission blockchain network. Then the question that may come to your mind, where would you need permission blockchain platform? So if you look at supply chain applications, you're actually dealing with maybe tens of warehouses or tens of distributors. So you pretty much know which distributors you're going to deal with. And you can actually set up a permission blockchain with these distributors. And this allows you to have sort of a high level of transparency, and these distributors, and all you need to do is just have a protocol in place upfront that explains how we are going to set up the blockchain ecosystem. That's all. So that's the difference between permission and public. Permission is set up between sort of the known organizations or known parties, whereas public is public, meaning anyone can actually go and participate in this ecosystem. Bitcoin and Ethereum are examples of public blockchain. And then this next question is transaction cost. So I mentioned that platforms such as Bitcoin and Ethereum uses this proof of work blockchain. And then if someone successfully solves this cryptographic puzzle, they will get a reward. So where is this reward money coming from? So this is coming from the transaction cost. So whenever you submit a transaction to Ethereum or Bitcoin, let's say that I want to transfer money from my account to Roger's account, you're required to pay a small amount of transaction fee. This could be maybe, I don't know, 15 cents or 20 cents, or it varies, depends on when you're doing this transaction. It could even go up to $1. So you would pay the small transaction fee on top of your transaction. So let's say that I'm sending 1 Bitcoin to Roger. I'll probably have to pay 1 Bitcoin. That is the money that I'm transferring to Roger. On top of it, I'll have to pay this transaction fee that is like either 20 cents or $1 or whatever. So there is transaction cost associated with each transaction. So when you're building a blockchain application, if you're submitting a lot of transactions to blockchain, you need to take into account this transaction cost. Otherwise, your application is going to incur a lot of money to do all these transactions. And the next is ownership and stakeholders, which I briefly touched on when I mentioned permission blockchain. So when you build an application, you need to think about who is going to own this infrastructure, meaning who is going to run these blockchain nodes, and who are the stakeholders in the ecosystem. And based on that, you can make a decision whether to use a permission blockchain or a public blockchain. And the next is the consensus algorithm. I mentioned that Bitcoin requires this cryptographic puzzle. It is very expensive. You're going to spend a lot of energy to solve the puzzle. Therefore, you need to think about whether you want to use such a heavyweight consensus algorithm in your blockchain. An alternative include this Byzantine fault tolerant consensus or Tendermint BFT, which I mentioned a little while ago. If you use that, it is very lightweight. It's going to be extremely fast. So you have various options here. You need to think about which options you want to choose in terms of the consensus algorithm. Next is the smart contract. Do you want to automate some of your business processes in the blockchain? If that is the case, you need to choose a blockchain platform that already supports the smart contract capability. Please note that not all the platforms today supports this smart contract. Only a handful of them have the smart contract capability. Therefore, when you're choosing a blockchain for your application, it is important to look at whether you need smart contract. If that is the case, then you need to choose a platform that provides support for smart contract. And the next is the interoperability. So this is again an important problem. So let's say that you have a legacy infrastructure that you're using for your, let's say, supply chain application, and you want to connect this legacy infrastructure with blockchain. Then you need to think about what are the options out there to connect your existing infrastructure with blockchain, because connecting sort of a legacy software is blockchain legacy software with blockchain requires a lot of effort. You don't want to go back and sort of build a new software to do your businesses. So you need to look at what you have at the moment in terms of infrastructure, and then how you can actually connect that infrastructure with blockchain without introducing major disruptions to your operations. So that's what I meant by interoperability. In some cases, you may also want to deal with multiple blockchains. Again, that's another challenge that one has to deal with. Today, transferring a payment from, let's say, a Bitcoin account to an Ethereum account is not a straightforward process. It requires a lot of complex operations. So again, you need to think about that as well. So those are some of the design questions that you need to take into account when you're building a blockchain-based application. And with that, I'm going to summarize this talk and conclude. As you can see, that Bitcoin started the whole blockchain revolution. It sort of removed centralized intermediary from handling all your transactions. It introduced a clever mechanism to build applications and architectures involving multiple stakeholders. And again, when you talk with many people, they think that blockchain is all about cryptocurrency, but it's not. Blockchain has a lot of other cool features that can be leveraged by many applications. Therefore, blockchain is not a technology only for cryptocurrency. It provides this features such as tamper-proof storage, which can be beneficial for many applications. And it provides ways to increase trust in multi-stakeholder environment. And again, thanks to the emergence of these blockchain technology, there are many practical and open source tools available for people to actually, experiment with and build a cool blockchain-based application. Yeah, so that concludes my talk, Roger.
Fantastic. Well, thank you so much, Dr. Ramachandran. Nilu, would you like to introduce the next speaker?
So yeah, thank you, Dr. Gowri Shankar. That was very informational to learn more about the real life application for blockchain. So at this point, I would like to welcome our second speaker, Alex Nascimento. Alex Nascimento is a member and co-founder of blockchain at UCLA, where he lectures on blockchain business applications and security tokens. He's also a managing director of 7cc Blockchain Investments, a company focused on supporting and fostering the blockchain industry. Alex received his MBA from UCLA and has developed training, marketing, and blockchain strategies for companies in the United States, Latin America, and Asia. He's also an author of a book, The STO, Security Token Offerings, Financial Revolution, which provides a comprehensive understanding of the global competitive landscape of security tokens. So welcome, Alex Nascimento, over to you.
Hi, Nilu. Thank you so much. Really appreciate. Let me try to share the screen here. Just in respect to everyone's time, how much time do we have for this?
So we can go for like about 25 minutes.
All right, I can do this in 25 minutes. So yeah, so like Nilo mentioned, my name is Alex Nascimento. As my day job, I run a strategy and investment firm focused on the blockchain industry called 7 Seas Blockchain Investments. And I teach at UCLA the business course of blockchain. It's a non-technical course, and it's open to the general public. So we have a session going on right now that starts on September 28th. It's online. So anyone in this audience, I welcome you to join the course. It's a 10-week course, and we go through the various business applications of blockchain and how it will impact a variety of industries, as well as how you can fundraise on the blockchain under all current laws and regulations, like fully compliant. So like Nilu mentioned, I wrote a book that covers that as the STO Financial Revolution. If you guys use this code here, is our latest code, STO Book Digitalks, and you go to the site, the STO Financial Revolution, you can get it for free. Or else you can find it on Amazon, and all the proceeds go to the UCLA blockchain lab and blockchain at UCLA Student Club. So cool. So little disclaimer here, I'm not a lawyer and this is not legal advice. I highly recommend that if you're going to go fundraising or develop any blockchain business process that it's open to the general public, you consult a lawyer. So like Dr. Gowri mentioned, blockchain creates these immutable files which cannot be replicated. I like to take this graph here in a little bit of context. Like if I take a picture of us all going to dinner or us all in a networking event, and I send to everyone who's here in the audience, everyone will have a copy of that picture. Now in blockchain, that's not the case. If I take that picture and I send it to Nilu, then I no longer have that picture. Now Nilu has that picture because it's a single immutable file. And then if Nilu wants to send it to Roger, then Roger now has that file. Neither I have a copy nor Nilu, right? So if you take that concept of a single immutable file, you can make that file represent a variety of different things with value and things without value, fungible and non-fungible, what we call tokens. So think about the token as kind of like this file on the blockchain that could represent a variety of different things. And that was the idea that started cryptocurrencies, right? If I have a single immutable file that if I send it to someone, I no longer have it, then that file could represent a currency or something else. Now, if you pair that with the advent of smart contracts and include smart contracts in that file group, then now you no longer have something of financial value, but you also can utilize that smart contract to represent an investment contract. And that's really where the rubber meets the road, because you can use these smart contracts to do any kind of financial transaction that we see in the traditional financial world, real estate, startup fundraising, energy trade, sale of art, and all these different things, right? So here is a very simple graph that describes how a smart contract like that would operate in a financial transaction, where the buyer wants to buy a house and he finds someone online that has a house. They both match in a smart contract that it's registered on the blockchain. Remember that smart contract is an immutable file, so it works just like your paper and pen traditional house deed, right? So, but that contract has automated execution clauses. So when the buyer sends the money to an escrow account and the seller of the house passes on the deed to that same escrow account, the logic of the smart contract starts triggering all these future events and then changes the ownership of the house and sends the money to the person who sold the house, right? So very simple, and also can update different databases like the local clearing house or the LA County property, database. So if we continue here, where does history becomes really important here? So in 2017, more or less 16, 17, a lot of these startup projects saw this opportunity of using a single immutable file to make those single immutable files represent a share in that startup, just like you fundraise any other startup, right? And then started raising money against those cryptocurrencies or tokens that represented a share in those projects. Now, if you look from a regulator perspective, a financial regulator perspective, and every country, every jurisdiction has its own, in the United States is the SEC, the Securities and Exchange Commission. That is a unregulated financial offering, right? The SEC regulates all types of public investments in the United States, right? And the SEC was not happy with it because the SEC wants to protect investors and make sure that whoever is distributing and selling financial products is doing so under a regulated format. So that's very important to make the distinction of why now security tokens are in vogue. Because utility token, which was very much used in 2017, should only be a token or a file that gives you access to something, right? It should not have monetary value, and it should not have an expectation of appreciation in price or in value. So like if I'm giving you money and I'm taking a contract that has the description of what you're going to do to grow my money or to give me more money back, then that is considered a investment contract and should be regulated. So here I have two pictures that I find metaphorical, because if you're old enough to go to Disney when they had the Disney dollars, you would remember that you had these make-believe dollar bills that only worked at Disney, and they give you access to buying an ice cream, access to going on a roller coaster. That's a utility token, and that's what an utility token should be. Now, if you're going to create an investment contract, that should behave very much like a Disney stock, right? You're buying a share in the company, and that should be regulated by the United States if you are offering within the boundaries of our country. So now that we understood security tokens, how can we use security tokens in a variety of different industries? I'll give you guys a few examples here. And I'm very happy to share my information. If you want to discuss this in more detail, just ping me on LinkedIn or join the class. Again, the class is open to the general public. It's online, and you don't need any technical expertise to participate or join it. And you will get UCLA credit for it. So a couple of different industries here that have been very popular for utilization of security tokens. Real estate, right? You can get a beautiful building on Park Avenue that is a few $100 million. And that is traditionally an illiquid asset because only a few people in the world have the money to invest in that. So you could fractionalize the ownership of that building to almost like $1 or even cents, most likely something like a share price of, $50, $100, and pulverize it all over the internet so that people could buy a share of that building. Startups, the same thing. You could do equity crowdfunding. And now in the United States, it's fully legal to do equity crowdfunding for startups using STOs. In July 2019, the SEC approved not only one, but two general public token offerings. Mature companies, SMEs, could also use security tokens to raise either debt or more money against their equity. Energy, we have a few clients that are doing energy or credits of energy stored on the blockchain. Remember again, the STO is a financial investment contract where it's stored on the blockchain, right? And it's self-executed. So you could buy future energy credits or future barrels of oils, just like you would do in the traditional world with a pen and paper contract, but now it's all self-executed. One of the beauties of this is that you almost reduce to zero the back office costs of running those contracts, which make it very much economically not feasible for many of these assets. And so another great example is a collection of art. So if you have a collection of Picassos at home or Rembrandts or any other valuable piece of art, you could fractionalize that piece of art and sell it through the web to investors that you've never met before. Funds are a big user of security tokens. There are a variety of VC funds and investment funds that are now using tokens. Again, one of the beauties of it is that it's reducing all the costs of back office of managing those shares. Here's a slide that if you're in the US and if you're thinking about it, doing a security token, I would highly recommend you take a screenshot. This is the ecosystem of a security token. Because this is a regulated smart contract on the blockchain, you want to make sure you have all these pieces. And these are in accordance with the SEC's regulation, right? So you need a custodian. Some of the companies here are Prime Trust and BitGo. You need someone to develop that smart contract. One of our supporters and that we work closely with is Polymath. In the United States and other jurisdictions, not necessarily, but in the United States, you need a licensed broker to sell securities. Coinbase does that. You also will need legal services to prepare your investment contracts. Fisher & Broyle is also a fantastic company here in the West Coast. And then you're going to have to list that share or that investment contract in an exchange. In the United States, where T0 is the most popular and relevant exchange. And obviously, you're going to have to be compliant and run KYC and AML procedures on all your investors to make sure that everybody that's buying your share or buying your token is a good actor. You're not dealing with anyone that's involved in illicit ventures like drug trafficking or terrorism. So one of the interesting things that I like to talk about is why security tokens, right? If this is an investment contract that is registered on the blockchain and self-execute, why couldn't I do that in just a traditional pen and paper format? A couple of things here, right? Cost reduction. Cost reduction of your back office is huge. Banks and investment banks estimate that they spend around $6 billion a year on just back office costs. And if you're running a smart contract, then you could almost bring that down to zero because it's a computer running it, right? Obviously, you have the costs of that IT infrastructure. A great example here is revenue sharing and dividend payments. When I go around the world and I give these talks, people get shocked that in the entire United States, only about 3,000 companies issue dividends. Why? Because it's so costly and so bureaucratic to make sure that you're paying the right amount to all your shareholders. But you can do that in an automated fashion via security tokens. Startup fundraising, a key aspect of security tokens. You don't necessarily need to take your investors to dinner anymore or try to go up on stage and pitch your idea. You could create a website, issue a security token, and market your website to a variety of investors all over the world. Obviously, lower risks of redemption. You could sell your security token on the secondary market, which is 24/7 and doesn't have frontiers because we're all connected on the internet. And you have a greater and more granular ability to really know who is the holder of that security. If anyone here remembers subprime loans, one of the issues was we didn't know who was the holder of that loan. It was just being repackaged and resold. But with a security token, that would be very much easy to solve. So different jurisdictions around the world are looking at this. The United States has a full approved legislation under the SEC. If you're curious about it, I would look at under the Jobs Act. I joke with my students that it has nothing to do with Steve Jobs. It's the jumpstart of our business startup, and it was under the Obama administration. And they're using that infrastructure and that framework, that legal framework, to issue security tokens. So fully regulated, you could do this, you would not be breaching the law. In countries like Japan, digital currencies are considered law. Singapore is a country that we work a lot with. Most of our clients either issue it in the US, in Singapore, Cayman, or Switzerland. Those are great jurisdictions for you to issue your security token. And I'm happy to have a more detailed discussion about it if you're interested. Here's a little bit of the historical timeline that happened, why it became a security token, and where is it going, right? And what the evolution of the industry. Like I said, in July 2017, a lot of investors lost money in the DAO scandal, which was a hack that happened in one of these ICOs, and millions of dollars were lost. After that point, the SEC started to look at this industry with a lot of caution and trying to implement regulation, including making Bitcoin a commodity, approving 2 token offerings to the general public. That means you don't need to be an accredited investor to buy it. You could sell it to anyone in the United States. That was props from our friend Adi Seidman and Blockstack. In November 2019, it considered Ether also a commodity. And some of the industry updates here is, for example, Polymath, which is a developer of security tokens and a lot of other products in the industry, is now releasing their blockchain fully targeted to security tokens. And then very recently, the OCC released an information saying that now retail banks will be able to provide custody of crypto as well as other digital assets like security tokens for their clients. So the industry is growing at a very, very fast pace, but we still have a few problems, which is lack of liquidity. We still need more people to be involved in this space. And the more people that get involved, the more liquidity we have, right? There is a little bit of unclear international regulation in some jurisdictions. And creating a common standard for security tokens is still something that the industry is working on. But there is a lot of opportunities. So if we consider that global equities represent around 70 trillion and bonds is around 92 trillion, and we have about 4.1 billion people on the internet, imagine how many more assets, securities you could bring to the general internet population by tokenizing startups, real estate investments, farms, SMEs, art. We have a close partner here in LA, Wave Financial, that they're doing a very interesting tokenization of barrels of whiskey, traditionally a very illiquid asset that now you could buy your share in a collection of barrels of whiskey, actually bourbon, and wait for it to appreciate and capitalize on those gains. If you don't believe me, here are some of the recent news. The largest Latin America investment bank is now paying dividends to one of its first security tokens. Red Swan and Polymath are tokenizing $2.2 billion in high-end real estate. I'm For those of you who ski in Aspen, the St. Regis Hotel in Aspen has been already tokenized and is being traded on T0. So there's definitely a lot going on in this space. But one of the things that excites me and was always our theory at UCLA and at our firm is that if this whole cryptocurrency blockchain environment was going to really catch to its potential was when institutional players, financial institutional players, would adopt it. And we've been seeing that at a very, very fast pace. So in May 2019, we saw the Chicago Mercantile Exchange that issues future contracts on the price of Bitcoin pass the volume of daily trade of Bitcoin. Fidelity Digital Assets has a full institutional product. Pension funds are buying digital assets. Bakkt, which is a custodian and digital asset solution built by the New York Stock Exchange, is now fully available for clients. Silvergate Bank is a crypto-friendly bank that it's listed on the New York Stock Exchange. Tezos platform and other platforms are helping banks and other financial institutions build these financial assets and issuing grants. There's $37 million there of grants. And then very lately, the macro investor Paul Tudor talked about in his investment letter about Bitcoin being a very good hedging strategy for this quantitative easing phase 2 that we're seeing here in this pandemic, where central banks around the world are just printing money. Some of the case studies here, just to, as we get to the end of what's being used, like I mentioned, the St. Regis Aspen Hotel is being tokenized. The Brazilian interbank settlement platform PIX is now taking Bitcoin and other cryptocurrencies. T0, which is the most popular exchange of security tokens in the United States, is breaking record after record. R3 Corda is a blockchain that involves over 50 banks around the world. SDX is the Swiss digital exchange, which is the sister company of the original Swiss exchange, stock exchange, that it's now dealing with banks to issue financial products on the blockchain and exchanging those blockchains. Quorum was a blockchain that was developed by JP Morgan Chase and was recently bought by Consensus, which is a venture arm based in New York. And we also have really close contacts with NASDAQ, who has been for the longest time a digital exchange, now has a full solution for security tokens, from issuance to custody to exchange platform. So this industry is real and it's taking over the financial world. Here are some of the regulatory changes that are affecting different jurisdictions. In light of time, I'm not going to go through them, but there's a lot of detail on these jurisdictions in the book, so I highly recommend you guys take a look at the book. It's $1 on Amazon, so if you are keen to it, please leave us a review, and the funds go to UCLA. So United States, Canada, Bermuda, Brazil, Cayman Islands, Bahamas, European Union, Liechtenstein, Gibraltar, Switzerland, Malta. Germany just said that Bitcoin is a fiat money. China, Thailand, Hong Kong, and all these other jurisdictions are looking at this as a solution. And what we think the future is going to be, if I had a crystal ball, is that we're going to see a lot more STO financing, like financial products, exchange listings, a lot more products being listed on these various exchanges, and different marketplaces going live. We see a lot of push for DeFi and decentralized finance recently. That's a whole new conversation. I'm happy to do another event like this to cover DeFi. But if you're into crypto, you know that it's going through the roofs, these DeFi tokens. crowdfunding and fintech companies also using STO services, and a much higher liquidity. As this gets adoption, more liquidity. And obviously new regulation that makes it clear and allows people to do cross-border transactions. One of the things that I like to say about security tokens is that it mimics Amara's law, right? Where we tend to overestimate the effects of a technology in the short run, but underestimate the effects of it in the long run. So my thesis and our work that we do at UCLA is very much based on this, as we believe that security tokens are going to be the new technology for financial systems, which is pretty much very much legacy technology or old paper and pencil technology. Again, a little piece of advice: if you're going to go through this, make sure you're in compliance with all the international jurisdictions, you get a good lawyer, and you keep reportings on your obligations and who is holding your shares. This is kind of my advice. And again, here, if you want to get the book for free, you can go to this website, use the code DIGITALKS to get it for free. If not, if you want to support us at UCLA, just go to Amazon, go to type in the STO Financial Revolution, and it is 99 cents. So hope this helps. I'm going to share my information with Nilu. Nilu, please feel free to share with the entire audience. I'm happy to chat with you. And if you're on LinkedIn, you can find me as Alex Nascimento, UCLA. I'll be the first one to pop on a black and white picture. Thank you.
Fantastic. Thank you so much for that insightful presentation. We have several questions from the audience, a couple for each of you. One question is, how much is one Bitcoin worth today?
I think 11,300, 400, depending on the time of the day you look.
Okay. And then another one for you, Alex. The question is, did I hear that the UCLA blockchain class is free? If yes, how does one register?
I wish. The book is free. If you go to the website, the book is free if you use this code here. But the UCLA blockchain is open to the general public. It does not require technical expertise, and you will get UCLA credit. And it's online. You can take it at your availability.
Okay. Okay, there's another question, and I believe this would be for Dr. Gowri. What are the best resources for learning blockchain?
Oh, that's a great question. There is a course in Coursera, which I believe is also free. It provides a high-level introduction to blockchain. This is given by Princeton University, I believe. So if you want to understand Bitcoin and how it works, that would be a good starting point. In addition, there are plenty of tutorials in YouTube, and as well as there are quite a few Medium articles that sort of walk through some of the platforms. Like, it introduces the basic concepts and how one can actually do coding, for example, how to write smart contracts and how to deploy it on blockchain platform. All these things are explained in few of the YouTube tutorials and Medium articles. I typically recommend some of these resources to students who are new to the space, so that they can follow this YouTube video and they can do these tutorials quite easily and pick up the concepts.
Okay, great. Another question, again for Dr. Gowri. Can anything be tokenized? Real-life assets, digital assets, personal information?
I believe so, but I think Alex could be able to provide a more detailed answer. But from my experience, the kind of things that I looked at, yes, it is certainly possible. And in fact, one of the projects that we looked at, we were actually trying to tokenize eco-friendly driving. So let's say that there are some routes in the in a city that are more eco-friendly. So if you take that route, you're reducing the traffic, and you're also reducing the air pollution, and therefore you can actually earn some carbon tokens by following the eco-friendly routes. And these carbon tokens can actually be used for buying what to say gas, or also paying for tolls and those type of things. Yeah, certainly it is possible. Maybe Alex can add more insights.
Yeah, no, I agree with Dr. Gowri. Anything from a financial point of view can be tokenized. I find it funny, and this is a little caveat here. Usually we do corporate education at financial institutions. And then a common question is all these financiers with a lot of experience ask me, so can I tokenize a debenture? I'm like, yes. Can I tokenize a real estate fund, a REIT? I'm like, yes. Can I tokenize a future contract of barrels of oil? I'm like, yes. And they tend to ask me is like, Alex, are you just saying yes because you believe in this, or can I actually do it? And the answer is you can actually do it, because a an STO and involving a smart contract is the representation of a traditional financial contract, pen and paper, with self-executing clauses, because it's a software and it's registered on a distributed ledger, which allows more people to have access to it and inter-exchange it. So with that kind of encompassing concept, I agree with Dr. Gowri. You probably tokenize anything.
Okay. There's two more questions. One, the first, how does one file and get issued blockchain patents? How does one file and get issued blockchain patents? Do you have any tips for new teams?
Sorry, I didn't follow the question. How did someone issue and?
File for a patent and get a patent issued for some kind of blockchain, a new kind of blockchain.
I would say go to the patent office, a patent attorney. I don't know, maybe Dr. Gowri has more experience in that.
No, I mean, I don't have specific details about patents. I believe it follows the traditional patent filing process. I don't think there is anything new to this. Perhaps one may have to look at what the blockchain technology or the application is going to focus on. And maybe it's important to look at the regulations for the kind of things that you want to do before you go for patent. But in terms of filing patents, I don't think there is anything significantly different to blockchain. So it just follows the traditional patent filing process as far as I know.
Okay.
Yeah, I'll give a little bit of an interesting point of view. So a friend of mine, Daniela Barbosa, who runs Hyperledger, which is one of the most popular blockchains out there, and coins the term, a blockchain of one is no fun. And I find that very insightful, because ideally, obviously, you could patent your blockchain, but if you don't have a community supporting it, then the whole idea of a decentralized ledger kind of loses its purpose. So most popular projects of blockchain are open source, which it invites more people, highly qualified coders and technologists and economists or strategists like myself to join that project and to try to improve it. So think about the blockchain as a community, and decentralizing that information will get your project a lot further. I'm not saying for you not to patent it, but traditionally what if history plays as guide is that open source software has seen more success in the blockchain space. I don't know if Dr. Gowri agrees.
Yeah, that's a great point. I totally agree with you. Yeah, because blockchain, one of the biggest selling point is it is decentralized, that it involves the community members. Therefore, you will have to be very careful when you are, filing patent, and also how you're, projecting your product, and how you are, sharing more information with the community. Most of the projects, or if not all, um, they have open source software. So if you, for example, look at Ethereum, if you look at Bitcoin, you can look at their software and you can look at the changes that have been made to the software over the past few years. And it's very transparent, it's open, because blockchain says it is for the sort of the free world, and everyone is welcome to freely participate. It's transparent. So therefore it's important to keep that in mind when you're going for this patent filing process.
Okay, great. One last question from the audience. This is apparently for Alex. If a company is valued at $1 million and it has $1 million of traditional stock outstanding, could it issue additional tokens beyond the $1 million in stock?
Yes, yes, very much so. It could issue, well, every company could issue more stocks, right? What you're traditionally happening there, you're diluting the original investors. If you want to bring, and that has happened in the history of security tokens, funds or SMEs have issued paper and pen, and I use just the acronym paper and pen, just like the traditional contract, paper and pen contracts, and then gave their shareholders the ability to represent that investment contract, that share, in a security token registered on a blockchain. So that if they would like to see liquidity, little funny example, like let's say I want to give it to my wife or I want to sell it to my uncle, then I don't need to go back and try to, rewrite and go back to the company and reissue the share. I could just update the information on their shareholder, assuming that shareholder is a good actor and passes KYC and AML procedures, then you have a lot more liquidity. And that's one of the advantages. So to your question, very good question, yes.
Okay. It looks like one more question came up.
Sure.
I think I know the answer to this. Is it too late to have an impact in blockchain? Oh. I'm assuming the person wants to develop things in blockchain. So the answer.
Yeah, no, you can, it's only the beginning. I would say the industry is truly like maybe 5 years old.
Yeah, and maybe I could add to Alex's answer. If you look at the kind of sensation around blockchain about 3 years ago, and if you look at it now, for example, if you look at the amount of developments or the number of new applications or new ideas being created in the blockchain space, there is certainly a dip, especially from the engineering and research point of view, because there are some fundamental challenge in creating a sort of a blockchain based application that is both efficient and sustainable in the long run. So certainly from the engineering point of view, we see a lot of open challenges. And in the last 1 year or so, we are starting to see a lot of new innovations on top of the blockchain technology that is making blockchain more and more efficient. But again, there are still so many other open challenges that we still need to address from the engineering standpoint. So therefore, we'll be seeing more and more new technologies, new applications, and new innovations happening in this space in the coming years.
Yeah, completely agree with Dr. Gowri. this has been said in the industry over and over and over again. I'm just going to repeat it. We're at the beginning of the internet, but when the internet was at its beginning, we didn't have as many people on the internet. Blockchain is during that first early 90s stage of the blockchain, but now you have 4.1 billion people that could potentially access it.
Fantastic. Well, thank you, gentlemen, both of you, for the insightful presentations.
Thank you.
Thank you.
Thank you, Roger. Thank you, Dr. Garrett. Thanks, Neil. Appreciate it.
Alex. Yeah.
Thank you. So we wanted to mention our upcoming events. So AITP-LA is very excited to present upcoming events in next 3 months. So we have an event coming up on September 24th. It's about managing remote teams, secrets and stories of managing successful virtual teams. It's a panel discussion, and we are excited to bring an all-women panel from diverse backgrounds. These women leaders will be sharing their experiences and providing tips for running successful virtual teams. We are also going to have a virtual networking before the event, and it's going to be followed by a brief presentation on best practices on project management. And after that, we are going to have the panel discussion. And then coming up in October, we have an event on 5G, Wi-Fi 6, and trends in wireless communications. And then immediately after that in November, we are going to have a panel on the chief technology officers discussing trends in innovation and disruptive technologies. So we have exciting events coming up for rest of the year. So I would say stay tuned. You can also go to the AITP-LA website and get more details or sign up for our newsletter so that you can know more about the upcoming events. So at this point, I'm going to thank you all our attendees for attending this event, and special thank you to our guest speakers, Alex Nascimento and Gowri Shankar.
Thanks again so much.
Great. Thank you.
We'll sign off for now.
Bye-bye.
Bye.